Okay, so this is the last portion of chapter 6, right? And you have here electron configuration. And another way to also to work with electron configuration is use a periodic table. So these elements here are the S block, that means all elements in this block here. The last electron will be in the S, subshell S. And these elements here are the P block elements. So the last electrons, these elements from this block here, they will be in the P block. The same thing for these elements, for the D, and here for F. Like sodium periodic table, right? Sodium is here. The third period is in the block S and in the first column for the block S. So the last electron for sodium is 3s1 that matches here, right? Sodium has 11 electrons, 1s2, 2s2, 4, 2p6, 10, 3s1, 11. Same thing for carbon. Carbon has 6 electrons in total, right? And the last electrons are right in this portion here. And you can see carbon is on the second period, P block, and it's the second line at the second column of the P block. So carbon is a 2p2. It's another way to check if you are doing the electron configuration correctly too. For C and C and P block, you can look at exactly the number for the period will be also your energy level. So energy level 1 for S for P block will be exactly the same number as the period. Like here. Sodium, 3s1, so 3 third period. So potassium is right here, right periodic table. So potassium is a S block element, so it will be 4s1. The last electron for potassium will stop right here, 4s1. So let's check that's true, right? So potassium has 19 electrons. Are you seeing here 19? What's the electron configuration for 19? So 1s2, 2s2, then 2p6. The next will be 3s2, then O3p6 here, and then finally the potassium is in the fourth period, S block in the first column, 4s1. Let's count if we have a really 19. 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus 1, 19, right? Potassium has atomic number 19, so 19 electrons. And in here, so the electron configuration and orbital diagram here. So hydrogen has 1 electron, so 1s1. The configuration, the electronic configuration for hydrogen is 1s1. The orbital diagram is just one arrow up here, right? Lithium has 3 electrons, so 1s2, 2s1, 2 plus 1, 3 electrons. So 1s2, 2s1, 1, 2, 3 electrons, right? First, we're gonna be up, up, up. let's do this one here. Carbon, 6 electrons, right? So 1s2, 2s2, and 2p, 2, right? 2 plus 2, 4 plus 2, 6. So how are going to be the orbital diagram here? 1s2 for this one, then 2s2 for this one, and then 2p2. So our same first semi drawing the arrows up, right? Nitrogen has 7 electrons, so 1s2, 2s2, and then 2p3. And it also makes sense, right? 2p3, you can see nitrogen is in the p block, and is in the third one for the p block, so the p3 here. And how we're gonna draw this orbital diagram here? 1s2 represents this portion, 2s2 this portion, then 2p3, 2p1, 2p2, 2p3, right? First, all arrows up for each individual subshell here. Then neon has 10 electrons, 2 plus 2, 4 plus 6, 10, right? And then we're gonna fill the orbitals, 1s2, 2s2, 2p6. And then sodium has 11 electrons, 1s2, 2s2, 2p6, 10 plus 1, 3s1. Fill up all the arrows here, 1s2, 2s2, 2p6, and 3s1. Sodium plus lost 1 electron, right? So here we'll have only 10. So the same electron configuration for neon has 10 electrons, will be also for sodium ion, because it also has 10 electrons. And the orbital diagram also will be the same, right? 1s2, 2s2, and 2p6, right? Make sure you fill up first, going up, and then return should be down, down, down. So now another way to write electronic configuration is called condensed condensed notation or shorthand notation, also called noble gas notation. Why noble gas? Because we're going to use the noble gas in brackets, only noble gas in brackets to write the shorthand notation. For example, sodium has 11 electrons, right? Sodium. So 10, 1s2, 2s2, 2p6, 10, and then 3s1, 11. Which noble gas has 10 electrons? Neon, right? So this portion here represents neon. So another way to write the electron configuration is just write neon 3s1. Done. Same thing for magnesium that has 12. Take the portion that means that represents the noble gas, in that case here. 10 electrons for neon, right? 10 and then 3s2 to complete the 12 electrons, right? For phosphorus, the electron configuration is 15. So 1s2, 2s2, 2p6, 10. That's going to be the neon configuration. 10, 3s2, 12, and 3p3, 15. So 3p3, right? So the noble gas configuration for phosphorus is neon, 3s2, 3p3, right? Then Phosphorus 3 minus means they gain 3 electrons. Gaining 3 electrons will want to be, we change from 15 to 18, right? So let's count in here. 1s2, 2s2, 2p6, 3s2, 3p6. So we count in here. The electrons are the number on the top. So 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18. Now you have 18 electrons. Which number gas has 18 electrons? Argon, right? So here, for this ion, your number gas configuration is just argon in brackets here, right? Okay, so, but you have two anomalies in chemistry, copper and chromium. So copper, the atomic number for copper is 29 here. So how do you want to be the electron configuration for 29? Let's count here until you have 29 electrons. So 1s2, 2s2, 2p6, right? 2 plus 2 plus 6, 10. 3s2, right? You are right here, 3s2. The next will be 3p6. Then the next one, 4s2. Now let's count how many we have now, right? So 10 plus 10, 20. Then the next, after 4s2, you have 3d10, right? 3d10. But because here should be 3d9 to get 29. What's happening here is anomaly is that the copper will be more stable if it is completely full. The orbitals will be completely full or filled or half filled. That is the case here. The S2, 4s2 will be 4s1 because the orbital D we change it to be from 9 to 10 electrons. And the 4s2 changes to be just 1 electron here. So the electron configuration for copper will be 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1 and 3d10. Because the stability. The atoms will be more stable if they are completely, the orbitals, the D will completely be filled, and for S will be heavy filled. So chromium has 24 electrons. Let's do the same thing here. 1s2, 2s2, 2p6, 10, right? 3s2, 3p6. Then 4s2, let's count how many we have. 10, 20, should be what here? 3d4 to make 24, right? What's the anomaly here? So D, the orbitals D, the subshell D, you have 5 orbitals, right? Oops, it's not the D4. D4 here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. But, so 3p4, 3d4 will be 1, 3, 4, right? What's happening here? This electron from the S2 will jump to the 3D. So here will be 4s1 and the 3D will be 3d5 because it's more stable when it's half filled or completely filled. 3d5 is more stable than 3d4. That's why chromium and copper, they are anomalies. that exception, right? So this, the end of chapter 6.